Okay, let's have a look at 7.3. I'm not going to go over all the review questions. I'm going to do selected ones. Okay, consider a system made up of two objects that collide with each other. Describe the difference between what happens to the system's kinetic energy when the collision is A. Totally inelastic, and elastic. Okay, so try this. Please try it. It really is beneficial to you. If you try it first, then you can see what you don't understand. Okay. Alright, so if you've got two objects moving, it doesn't matter how. This could be at rest, that could be that could be moving, this could be at rest, that could be moving, that could be both moving toward each other. The one could be, they could be moving away from each other, whereas that one is moving at a faster speed than this one. Eventually, somehow, they collide. Okay? There's a collision, there's an interaction. And so there's three types of interactions, really. We can have a totally inelastic, where they end up moving together after the interaction, or an inelastic, where they bounce off each other, but the relative velocities afterwards are not the same as the relative velocities before, and elastic, where the relative velocities after equal the relative velocities before. But the interesting thing here is, which we need to see, is that during the interaction, some of, or all of, it depends on the type of interaction, but some of the kinetic energy, or all, depends on the kind of interaction. Some of the kinetic energy is converted temporarily to internal energy, right? Internal energy. Remember, internal energy changes if you change the shape or the temperature. These are two examples, changing the shape or the temperature of the objects. So during this interaction, the shape or the temperature, specifically in our case, we're talking about the shape. Well, both, I guess, but the shape changes during the interaction, which means that your kinetic energy during the interaction, your kinetic energy goes down. Okay? So whether it's a totally inelastic, or elastic, all three of these types of collisions, your kinetic energy decreases. Okay? And it is converted to internal energy during the collision. However, for a totally inelastic collision, that converted kinetic energy, that was converted to internal energy, that does not get converted back to kinetic energy in a totally inelastic collision. In an inelastic collision, some of that kinetic energy which was converted to internal energy gets converted back. Right? In an elastic collision, the kinetic energy also gets converted to internal energy. Right? But in an elastic collision, that internal energy all of it gets converted back to kinetic energy. Okay? So what do we need to do? We need to see that in all kinds of collisions, whether it's elastic or totally inelastic, whatever, kinetic energy gets converted to internal energy, but the different types of collisions tell us whether the internal energy gets converted back to kinetic energy or not. Okay? I hope that's helpful. Cheers.